Hello, hello, can you hear me? Oh, you can. Oh no, I realized I just now I mute everybody, then I mute my own self as well. Sorry, everybody. So let's try this again. I'm gonna change my screen again. Okay, let's redo this. My apologies. Okay, my apologies on this. So let's restart again. So for this particular chapter on qualitative analysis, we are looking at how we can identify the cation in a salt. Salt generally contains a cation and an anion. Okay, and how do we identify them? We will normally test what the cation is, and then from there we'll determine what's inside based on the results. Okay, based on the results itself. Okay, now so in this particular chapter, qualitative analysis, because you can see here the word analysis here, what we're trying to do is really to find out what is the cation and anion and compound based on the test that you're doing and the results that you're getting. So it's important to always think of what's the test you're doing and analyze based on the results that you're getting. So these are the two main portions that we're going to focus on, what the test is and what's the results. Okay, so I've done this in the practical. So now it's really about applying it into your theory. Okay, if all is okay, put a thumbs up. Come practice, put a thumbs up. Okay, good. Okay, Ken, so let's carry on. Okay, so now what we're going to do here, we're going to start with the question one. So there are state the two reagents or solutions which can be used to test for the cation. So in general, to test for cation, we can use either one of these solutions. The first one is actually your sodium hydroxide. Okay, so not just know the name itself. To be more precise, it's actually your aqueous sodium hydroxide because it must be in solution form. So this is actually your NaOH aqueous. Let me put a square bracket like that. So this is the first thing, which is the aqueous sodium hydroxide. You can add it, look out for precipitates, okay, to find out what is the cation present. The other one you can look out for or use is actually aqueous ammonia. Okay, aqueous ammonia. So usually you'll see it as bracket. Let me erase this. You normally see as NH3 bracket aqueous. So this is your aqueous ammonia. Now, what is exactly happening in aqueous ammonia is that when you put ammonia inside water, so it will dissociate to give you ammonium cations plus hydroxide anions. Okay, the anions here from the aqueous ammonia and the anions here from the aqueous sodium hydroxides are the ones that react with the cations to give you your results. Okay, to give you your test results. Okay, so we're gonna now zoom in. Okay, we're gonna now zoom in on the various results from the test. So for this particular column over here, we are gonna see the results from adding aqueous sodium hydroxide. Okay, so we're just gonna go down, go row by row. Okay, then for this one here, we're gonna see what the results is from adding aqueous ammonia. Now, can you all just help me to change this to aqueous ammonia? So should be this one over here. Okay, put a thumbs up if so far okay. You're gonna hear me say this quite often, so it's just for me to check that you're following through with me. If any point in time you got any questions, just feel free to unmute yourself and ask me. Okay, now let's go. Okay, now so let's start with the first three. Now these three cations, if you do the test for the cations using sodium hydroxide or aqueous ammonia, they will normally give you a colored precipitate. PPT stands for precipitate, and most of you would have known already. So copper, iron 2, and iron 3, they give you colored precipitate. Okay, colored precipitate. So let's start from the first one. So for copper 2 ions, if you add sodium hydroxide to it, you're going to get a blue precipitate formed, which was insoluble. So that means this blue precipitate doesn't dissolve at all. So you add more and more sodium hydroxide, it doesn't dissolve. Okay, so what you have initially, think of it as I got a solution. This is a solution. after I add sodium hydroxide, okay, after I add sodium hydroxide, what's going to happen? I'm going to have my solution here, but then I'm going to have a blue precipitate. So you see solid forming. The blue precipitate is a solid that's formed. And if you add excess, so you add some more of sodium hydroxide, it is insoluble. That means it will not dissolve in excess sodium hydroxide. That's what they mean by this particular portion over here. Now, so that's for copper 2 ions when you are adding sodium hydroxide to it. Now, for copper 2, what if I add aqueous ammonia? Is there a difference in terms of the observation? Is there a difference in terms of the results? So whenever you look at the observation, actually you're looking at the results. So what exactly is the difference in results? There is a difference. So once again, copper 2 will actually form this blue precipitate. Now, if you use aqueous ammonia, this is where it gets interesting. It gives this, okay, so the blue precipitate form, which was soluble in excess aqueous ammonia to form a dark blue. Okay, instead of deep blue, change the word to dark blue. Okay, to form a dark blue solution. So you can see the observation differs. Okay, both although give blue precipitate, one is insoluble in excess sodium hydroxide. The other one, when you do a new test to it, it is actually soluble in aqueous ammonia. Now, so whenever you got this result, you can conclude. Okay, I say only when you have these results over here, then you can conclude that copper 2 ion is present. Why? Is because the blue precipitate that you see is copper 2 hydroxide. Okay, this blue precipitate that you see in the solution is unique. It is actually copper 2 hydroxide that's forming. So what's the formula for copper 2 hydroxide? It is Cu bracket OH2. Okay, solid, because it is a precipitate. Okay, so thumbs up if so far the first row is okay. Then I will speed up if it's okay already. Any questions for the first part? Thumbs up, okay? Okay, the rest I assume that you thumbs up. Can Okay, the thumbs up also is to make sure that I can see that you're following through with me as well. Okay, next. Now, for iron 2 and iron 3, I'm going to do it concurrently now. Now, for iron 2 is a Fe2 plus. You're going to get a green precipitate, which was insoluble in excess. So you're going to get a green solid, and when you add more sodium hydroxide, it doesn't dissolve. And you realize for aqueous ammonia, those of you remember in the practical, this is also a green precipitate, but also this is insoluble in aqueous ammonia. So you realize the results are the same. Okay, the results here are the same. And what you will know is that you can conclude once you see the green precipitate is that Fe2 plus is present. Why? Because the green precipitate formed is actually your iron 2 hydroxide. Okay, it's important to know the formula. There's quite a fair bit of formula writing inside this particular chapter as well. Normally, these are the last 1-2 marks in this particular question whenever it forms. Well, you're going to see it later on, okay, in the worksheets. Okay, now going to go on to iron 3. Iron 3, what you're going to get is a reddish brown precipitate. Okay, which is insoluble in excess, sodium hydroxide. So same one, you realize it is also the same across both sodium hydroxide and aqueous ammonia. You're going to get this reddish brown precipitate. Okay, the colors, the writings are important. So make sure that you identify the colors correctly and write the correct term. Red will not be acceptable. Brown will not be acceptable. Please, I just want to see reddish brown. Okay, so Fe3 plus, if it is present, you're going to see this reddish brown precipitate, which actually represents your iron 3 hydroxide. And that is your Fe bracket OH3. Okay, look at the way how the formula is formed. So this one here, okay, I'm going to pause here now. I'm just going to go back to the formula. So to get the CuOH bracket 2 is actually 1 copper 2 plus 2 hydroxide ions. Both of them are equals to give you your copper hydroxide solid precipitate. So for this one, Fe2 plus or iron 2 hydroxide, you actually got Fe2 plus equals 1 reacting with 2 hydroxide ions aqueous. Okay, AQ over here. to give you your FeOH2 solid. I'm just going to write for the iron 3 as well. You're going to get Fe3 plus, because it's iron 3, aqueous. OH minus, aqueous. You got 3 of them from the solution. And tada, you get your FeOH3 solid. Okay? Now, so then the question is here. I'm testing for cation ions. Okay, based on the results, I know copper 2, iron 2, iron 3. Okay, where did the copper 2, where did the iron 2 and iron 3 come from? So back to the very original part, remember that this is qualitative analysis. You're trying to find out what is in the unknown. So usually, what you're going to have, I'm going to scroll down a bit, okay, in this blank space here. Normally, you have a test tube, there's an unknown X. You want to find out what is the cation ion inside X. You want to find out what's the anion inside X. Okay? So therefore, to test for the cation ion, you will, in X, add in sodium hydroxide, or in X, you will add in aqueous ammonia. Okay? And whatever results that you see, okay, in terms of precipitate, you will determine what's the cation ion that's present. Okay, so far we are only testing for cation ion. And to test for cation ion, you use sodium hydroxide aqueous, or you use aqueous ammonia. Thumbs up if so far all okay. Just to check everyone's around. Okay, let's carry on here.
Mr. Eugene,
Yes.
Blaine says he's trying to join, but he's not being let in.
Oh yeah, I let them in there. Yep. So I have to focus on trying to explain the thing. Okay, let's carry on. Now, let's go on to zinc, calcium, and aluminium. Now, this next 3 over here, I wouldn't say they are colored. They're actually white. Okay, so whenever I say colored, it means like really got color, like blue, red, reddish brown, green. Okay, but for zinc, aluminium, and calcium, this one are white precipitates. So it is harder to differentiate between these 3 because they don't have a distinct color. All 3 of them give you white precipitate. Okay, but the difference is that you realize they give different results in aqueous ammonia and in sodium hydroxide. Okay, so let's go through this. I'm going to do column by column now. I'm going to do this column first. Okay, so the way I'm going to do it is slightly different. I'm going to do this column first. Okay, so first part, zinc ion. When you add sodium hydroxide in, you're going to get a white precipitate. Okay, so you're going to get white precipitate formed. And when you add excess sodium hydroxide, this is actually soluble. That means it will dissolve and it will give a colorless solution. Okay, so zinc, when you add sodium hydroxide, you'll see white precipitate, and then it will dissolve in excess sodium hydroxide to give you a colorless solution. Okay, so this one can dissolve. So I just write here, can dissolve in excess. Okay, aluminium. You are also going to get white precipitate when you add excess sodium hydroxide. Same thing, this guy here is soluble in excess to give you a colorless solution. And hence, this guy also can dissolve in excess. Okay, so based on the zinc and aluminium ion test, or cation ion test, you realize that both give me the same results. So if I add sodium hydroxide, actually I cannot differentiate whether is it going to be zinc ion in the solution or whether it's going to be aluminium ion in the solution. Okay, so I tell you first, if you add sodium hydroxide, you cannot differentiate between aluminium and zinc because the results are the same. Okay, you get the same results for these 2, same results. So sodium hydroxide cannot differentiate between aluminium and zinc. Cannot. But calcium can. Why? Because calcium, you get white precipitate. So it's the same one. But the white precipitate is insoluble in excess sodium hydroxide. So you realize this one is cannot dissolve in excess. So by adding sodium hydroxide and having a white precipitate that's insoluble in excess, you can conclude that it's calcium ion. Okay, so sodium hydroxide can help you differentiate to know that calcium ion is present instead of zinc and aluminum. Okay, so I've done the first column already. Now I'm going to go on to the second column where I'm adding, this is our adding aqueous ammonia. Okay, how to differentiate between these three are? So let's start from the bottom first. For calcium ion in the solution, if you add aqueous ammonia, there's no observable change, meaning that there's no precipitate formed. Okay, so even aqueous ammonia to calcium ions in the solution, right? That if you add aqueous ammonia to the solution that contains calcium ion, you realize that there's no precipitate formed. Okay, so this sets itself apart compared to the other two. Right? Now, having no precipitate form, please, that is not a conclusion. That's not a conclusion to say that calcium ion is present. You need to have this to conclude. Conclude that Ca2 plus is present. Okay. Take note the no precipitate form, that's not, or the no observable change, you can't conclude anything. Take note. Okay, next. Let's go on to zinc and aluminum. Let's start from zinc. So for zinc ion, if I add aqueous ammonia, you're going to get white precipitate formed. And this guy here is soluble in excess. This white precipitate is soluble in excess to give a colorless solution. So this one can dissolve in excess. So you realize for zinc, it is the same across both sodium hydroxide and aqueous ammonia. For aluminum ion, you're going to have a white precipitate also, but in this case, it is insoluble in excess aqueous ammonia. So this one cannot dissolve. So you realize I can differentiate now between zinc and aluminum because if I add aqueous ammonia, the white precipitate forming for zinc will be dissolving in excess. For aluminum, it cannot be dissolving in excess. Okay? So being able to differentiate between the three different cations, the white precipitate ones, they're important. Okay, so let's go on to this part now. So in terms of conclusion-wise, if you add sodium hydroxide, as I mentioned, you cannot differentiate whether it's zinc or aluminum present because both give the same results. But if you add aqueous ammonia, you can differentiate between the three white precipitates. Okay, zinc 2 plus is present because you know that the white precipitate formed is the zinc hydroxide over here, which is Zn bracket OH2. Okay, so whether you add sodium hydroxide or whether you add aqueous ammonia, the white precipitate that's formed is actually your zinc hydroxide. Next one for aluminium. Okay, once again, the white precipitate formed is actually aluminum hydroxide, which is Al bracket OH3. Okay, this is solid because it's a precipitate. This is solid, which is because it's a precipitate. And the last one, calcium hydroxide, is the white precipitate form. This is Ca bracket OH bracket 2, solid. Okay, do take note. When you say it can dissolve in excess, actually you are looking at this solid dissolving. So when we say it dissolves in excess, we're actually looking at the white precipitate here dissolving. Okay, so this hydroxide can undergo some further reaction for it to dissolve. Okay, I won't go through what is the exact reaction because you're not expected to know that particular chemical reaction itself. You just need to know that this is what can happen, but you don't need to know the exact chemical reaction in terms of the equation and stuff like this. Okay, thumbs up so far for these three white precipitates. Okay, good. Okay, so I'm going to go on to the last one. So you realize that there are total 7 cations that you need to identify. 3 of them are colored, 3 of them are white. Then the last one is an interesting one. It is an ammonium cation. How do you know ammonium is present? It is when you add sodium hydroxide. Okay, no precipitate form, but after warming it, so you need to warm it. This warming part is important. Okay, you're gonna get a colorless pungent gas being evolved. This gas turns moist red litmus paper to blue, which then tells you ammonia gas is produced, and then hence ammonium is present. Now, what exactly is happening here? Actually, what you're doing is a ammonium salt. Sorry, I'm spelling wrong. Yeah. Let me rewrite this. Okay, so what's actually happening here is your ammonium salt reacting with your alkali, which is your sodium hydroxide. Alkali, I'm just going to write alkali here, but actually I'm looking at NaOH. What you're going to get is your salt plus water plus ammonia gas. So actually, you're letting the ammonium salt undergo this particular reaction. And when the ammonia gas is produced, you know that the ammonium cation is present in the unknown, in the salt itself. Okay? So we are done with the test for cation here. I want us to now look at some questions. Okay? Want us to look at some questions. Okay, this is where get ready for me to call your name, then you unmute yourself, okay? Okay, so first one, aqueous sodium hydroxide is added. So if I add aqueous sodium hydroxide here, Darian, can you help me? Can you unmute yourself first? Can you unmute? Can talk now, Darian. Are you there? Hello. No, he can't talk. There's a Chure. Come. Chure can talk now. You don't give me thumbs down. Alright, Chure, come. If you add aqueous sodium hydroxide, what are you testing for in a QA? What do we just went through this whole thing here? We are testing for it. Start with C. Can't talk. Just now I hear you talk. Why you say you cannot talk suddenly? Okay lah, you all win. All don't talk to me. I very sad. I want to cry already. Who want to talk to me? Anybody? Edward, come. Edward, since you thumbs up. Edward, come help me.
Is it
That's what?
are we testing for copper?
No. Don't think of the specific one. If you add sodium hydroxide, you're not testing for copper specifically, right? You're testing for all of this, right?
Okay.
So what is all of this here called? So I see.
Things that are tested like sodium hydroxide.
Think of an animal.
Cat ion.
Yeah. So you're
Oh.
testing for cation. So always go for the general idea of what you are doing first. So if I'm adding aqueous sodium hydroxide, in this case here, I'm testing for cation. Okay, so that's correct. Next, this is the test. Okay, so we're looking at test. The result is blue precipitate formed, insoluble in excess. So this is the result. What does the result tells me? What is the substance that's formed? So what's the precipitate that's formed? Anyone help? Edward, continue.
Copper.
No, copper is not the precipitate that's formed. What's the precipitate?
It's actually 3, 4.
If you scroll up all the way to the top here, what's the precipitate that's formed when you see that blue precipitate? Anybody want to help? Yes. You just unmute yourself, then you can just share.
So you're basically testing for copper to high. We're basically just testing for copper to ions, right?
Yes. What's the blue precipitate?
Copper to hydroxide.
Yep. Okay, so being able to identify, being able to identify what the precipitate is important. Okay, so the precipitate is copper 2 hydroxide. Okay, so when you add sodium hydroxide, whenever you see the precipitate is a hydroxide. It's copper 2 hydroxide here. Okay, then what's the cation in the salt? Is actually what Damien mentioned, is your copper 2 plus ion. Or you can call it, if you want to write the formula, is Cu2 plus ion. Or the other one, you can write copper 2 ion. Okay, so that's for question 3. So you can see here, test for cations, what's the result? Okay, for the next one, this is once again test for cation. I'm not gonna like bore you, just asking you to say the same thing again. The result is white precipitate formed. So this is the result. White precipitate formed, insoluble in excess, equals sodium hydroxide. So white precipitate formed, but this time around it's insoluble in excess. Okay, anybody wants to help me? You can type in the chat. I'll let you type. I can see what you're typing, so don't worry. Anybody want to type? What do you think is the precipitate formed and what is the cation present? Okay, good. I can see you're typing. Okay, good. So the precipitate form here is actually your calcium hydroxide. So I think by some of your replies, you already know that every time when this test for cation results comes out, the precipitate form is always something hydroxide. Okay, depending on what's the cation, the name of the hydroxide will change. The cation present in the salt will actually be my Ca2 plus ion. I realize my Ca and my Cu looks very similar, so just take note. Be careful. This one is calcium ion present. Okay. Question 5. I'll let your I realize all is the same. I thought I'll do a new question 5, then 6 and 7 you're going to do. Okay, question 5, 6 and 7 is homework. You're all going to do homework. I just want to go through question 5, last one. So question 5, I add sodium hydroxide. This is the test. The results is I warm it and a pungent colorless gas produced. The gas turned moist red litmus paper blue. What's the chemical name of the product form? In this case, there's no precipitate. Okay, the product that's formed is this pungent gas. So this is the product. So can anyone help me type what do you think is the chemical name of the product form? Okay, so the product name is ammonia. So ammonia gas is the product that's formed. Because ammonia gas is formed, the cation that's present, cation present in the solution or in the salt is NH4 plus ion, or we can call it also the ammonium cation. So just take note of this ammonia versus ammonium cation. Be familiar with the terms. Okay, NH4 plus is ammonium cation. The gas that's produced is ammonia gas. Okay, know the difference between ammonium and ammonia. Okay, so this is until this part, 6 and 7, you all can do as homework. Okay, question 8, so that you'll do as homework. Okay, so you all can take this time, go and do already. You all can take pictures, send to me, that I can confirm for you whether you're correct or wrong. Okay, so I'm gonna keep all these questions for you to go and do as homework. Okay, there you can send it to me on your own. Okay, the next one I'm gonna do will be the test for anion. Okay, test for anions. So it is a similar thing. Okay, just as I mentioned, qualitative analysis to find out what's a cation, anions is present. You are doing tests, and from the results determining what's present in the salt or what's determining what's happening. Okay, so now anions is a little bit different because cation, you realize for cation, to test for it, you actually use only 2 things only. You use either sodium hydroxide equals sodium hydroxide, or you use equals ammonia. Okay, either one of this. Once you add them, then just look out for precipitates. Now, for anions, there's different anions requires a different test. So you realize there's these 5 main anions that are required to know. So carbonate, sulfate, chloride, iodide, and nitrate. Okay, so I'm just going to go through them row by row. Okay, row by row. So let's start. Carbonate. Okay, to test for carbonate, because it is a carbonate, right? I'm actually using a carbonate reaction. So I'm going to add acid to the substance. Usually I'll add nitric acid. Okay, this will be my common acid that I'll use. Okay, in experiments as well. So I add nitric acid to the substance. What I'm trying to do is to do an acid plus carbonate reaction. What I'm going to get is a salt plus water plus carbon dioxide gas. So if it's a carbonate present, right, acid, my focus is to see whether carbon dioxide gas evolved. Okay, if carbon dioxide gas evolved, I will know that carbonate is present. Okay, so after I add acid, what is the, to be more precise, this is actually the positive observation. That means what's the observation I should see if carbonate is present? So first thing, if carbonate is present and then when you add acid, you're going to get effervescence, which is that bubbling. Okay, so effervescence here. After that, you're going to determine what's the color and the odor of the gas. So I know carbon dioxide gas is evolved. So actually, if you ever do the test, realize that you're going to get a colorless, odorless gas that's evolved. Now, once the colorless gas is evolved, okay, you realize that I can rule out ammonia, I can rule out chlorine gas, I can rule out sulfur dioxide. Okay, I'm just left with hydrogen, oxygen, and carbon dioxide. Okay, but because you add acid, you know that carbon dioxide gas is going to get evolved, right? So I'll just prepare my lime water. I'll let the gas bubble into lime water. So think of it as this is my carbonate plus acid. Okay, I'm going to put a stopper here. I'm going to deliver this into my lime water. Okay, sorry for the ugly drawing, but yep. I'm going to bubble it into lime water. And when it's bubbling into the lime water, what you're going to get is a white precipitate form. This white precipitate formed tells you that carbon dioxide gas is evolved. Okay? So, I realize this is a repetition. Sorry, not repetition. So, based on all these tests, you realize that carbon dioxide gas is evolved, which then you can conclude that carbonate is present. Right? Carbonate is present. Now, a lot of questions that you might see in the question papers in theory, they might sometimes ask you to, what is this white precipitate that's formed? Okay, so the white precipitate in lime water is actually calcium carbonate. Okay, I'm going to show you what actually happens. So I'm going to write the reaction here. Lime water is actually calcium hydroxide. I'll write wrongly. Sorry. Okay, it's actually calcium hydroxide. This is aqueous. I add carbon dioxide gas in. So I bubble the carbon dioxide gas in. Now, when these two things react, you're going to get calcium carbonate, which is your white precipitate, and you're going to have water evolved. This calcium carbonate is your white PPT formed. Okay, so this is actually what's happening each time when you bubble the carbon dioxide gas into lime water. Okay, that's why you actually get a white precipitate form. It's actually calcium carbonate forming because your CO2 is reacting with the calcium hydroxide. Okay, so this is how you test for the carbonate. Every time you add acid will react metal, base, or carbonate, right? That's why carbonate tests, if you know CO2 is produced, you know that carbonate is present. Okay, so that's actually how this particular test works. Okay, next one, sulfate. Now, sulfate, first step you're going to add is add nitric acid. Okay, the purpose of adding this nitric acid here, okay, is to make sure carbonate ion is not present. How do I know carbonate ion is not present? Because if I add nitric acid, then effervescence produced, then I know carbonate is there. So I always add nitric acid first to make sure that there's no carbonate present. Okay, so you add nitric acid to eliminate or remove the possibility of carbonate. After that, then you add aqueous. Okay, take note, this is barium nitrate solution. Okay, so every time when you see the word barium in QA, in qualitative analysis, every time you see barium being added, right, barium nitrate. Actually, what you're trying to test for is actually sulfate. Right? Test for sulfate. Now, barium nitrate is one of the things that can be added. Sometimes you will see question papers saying that you add barium chloride. Either one is fine, barium nitrate or barium chloride. My suggestion is always go for the barium nitrate options if you can choose. Okay? Now, if I add barium nitrate, what I'm going to observe is white precipitate form. Okay? If you see this white precipitate formed, you can conclude that sulfate ion is present. So if you add barium nitrate, you get white precipitate form, you know that sulfate is present. Why? It's because actually the white precipitate formed is actually barium sulfate. So I got an unknown solution, okay, X. I add in barium nitrate. Then you get a precipitate here. You got some precipitate here. This is barium sulfate. So you realize, I added barium in. Then where did the sulfate come from? The sulfate must come from my X. Okay, the sulfate must come from my X in order for the barium sulfate to form. So that's why barium nitrate, when you add and you see the white precipitate form, you can conclude that my solution must contain sulfate. Otherwise, I cannot get a white precipitate forming. Okay. Now, one of you asked is, can you add barium nitrate first without adding nitric acid? Will that affect the results? Yes, that will. Okay, yes, that will. Because why? I just let you know, the white precipitate, if you never add nitric acid in, if you never add nitric acid, if no nitric acid added or no acid is added, if no nitric acid added, white precipitate could, I say again, could be also due to barium carbonate. So barium carbonate is also a white solid. So if you have a solution that contains carbonate as well, and you add barium inside, you actually also get white precipitate. So what you want to do is you want to add the nitric acid in to eliminate the possibility of carbonate being present first. So that you know that when the white precipitate forms, it will confirm guarantee plus chalk, it will be a sulfate. Can? Okay, so that's for this part. Okay, after going through this two, you realize the theory quite a fair bit. Any questions so far? Thumbs up if all okay. Not raise hand, use the send a reaction. Then after you press the thumbs up, okay? Can Okay, now just want to at this small part over here, I'm going to write down what's actually happening. When you have the barium sulfate forming, the solid, this is actually formed because you got barium from the barium nitrate reacting with the sulfate from the unknown. So actually your barium 2 plus will react with your sulfate from the unknown solution to give you your barium sulfate, which is a solid. So this is the main reaction that's actually be happening each time when you have your barium sulfate forming. This is actually the ionic equation. Okay, you'll see sometimes they'll ask you to write for the ionic equation of this. So you realize it's just the barium plus the sulfate to give you your barium sulfate. Okay. Next one. Fluoride ion, iodide ion. These are actually what we call halides. Halides are actually your halogen ions. Okay, so whenever you see the term halides, nothing too special. It's just telling you they are your halogen ions, which are actually your group 17 elements. Okay, group 17 elements are known as halogens. We'll cover this a little bit more when you reach the chapter of periodic table. Okay, so let's carry on. Chloride iodide tests, they have the same test, which is when you add, first thing you add nitric acid, once again, is actually to eliminate the idea of carbonate. After that, you add silver. My spelling looks like crap again. Sorry. After that, you add silver nitrate. Okay? You add silver nitrate. Now, so what is this thing here about adding silver nitrate? What is so special about this silver nitrate being added? Okay? So silver nitrate, the silver there actually causes a precipitate with the halides. So it could either precipitate out the chloride or can precipitate out with or can precipitate out. Okay, so it will precipitate out the halides. So it could be either chloride or it could be iodide. Okay. Now, so question is, how do I differentiate between chloride and iodide? Right? How can I differentiate between chloride and iodide? So chlorides will actually give you a white precipitate. So if I add silver nitrate and chloride is present, I'll actually get a white precipitate forming. Okay, now this part here, I put a star here because it's extra. It's really extra, like a bit, think of it as it's a bit out of syllabus. It's out of syllabus. You're not expected to memorize this and to know this. This is mainly to help with practical in case this is being asked in terms of the test. So sometimes they will ask you, okay, after adding nitric acid, add silver nitrate. Then sometimes they ask you add aqueous ammonia after that. Most people are confused. They're thinking, here, isn't aqueous ammonia test for cation? How come I do it after this halide test? Okay, this is actually an added reaction for the halide test. Okay, this is where it's interesting because if you add aqueous ammonia subsequently, the white precipitate that you form here will actually dissolve to give you a colorless solution. So the aqueous ammonia actually causes the white precipitate to dissolve. This is not test for cation, please take note. This is not test for cation. Okay, this is not. I say this is not test for cation. This is like extra test. Okay, that you don't need to remember in the theory side of it. This is really more for practical, where you sometimes may be asked to do this test, but you're not expected to know what the exact result is. You're just going to observe and write down observation. Okay, but people get confused with this because they thought it's a cation test. So just take note. Now, so once you see the white precipitate formed, actually you can just straight away conclude chloride is present. The white precipitate that you see here is actually silver chloride, which is your AgCl. Okay, so what's actually happening is that the silver from the silver nitrate, the chloride from the unknown solution, they will combine to give you AgCl in the solid state, which is your white precipitate. So this is your white PPT. Okay. So take note of this. In terms of the chloride ion, you use silver nitrate, you get a white precipitate. Then say, sure, then how about iodide? Will it also give you white precipitate? Answer is no lah. Okay, it will actually give you a different color, and hence you're able to differentiate between chloride and iodide. So for iodide, if it is present, you're gonna get a yellow precipitate instead. Okay, you're gonna get a yellow precipitate. Now, once again, I say again, this is our syllabus. So you are not expected to memorize this or know this. Okay, but this is good for your practical knowledge. As I mentioned, they can ask you add aqueous ammonia subsequently. So for this guy here, the yellow precipitate, now take note, this one is insoluble in excess. Alright, insoluble in aqueous ammonia over here. So you add aqueous ammonia, doesn't dissolve, you will just see the yellow precipitate remaining there. Okay, so by having the yellow precipitate, you will know that iodide is present because the yellow precipitate that's formed is actually your silver iodide, AgI. So I'm going to write the ionic equation. So silver from the silver nitrate equals iodide from the testing, from the solution they are testing, will give you your AgI solid, which is your yellow PPT. Okay, the last one, which is your nitrate test. Okay, the nitrate test is actually the most troublesome one because this one, the test really takes a lot more time. So what you're going to do to test for nitrate, this one here, first thing you're going to add is add sodium hydroxide. Okay, sodium hydroxide. After that, you add aluminium foil. Or aluminium powder. And then, so you can see I add sodium hydroxide, add aluminium. After that, you must warm gently. So there's 3 things to do to test for your nitrate. I say again, there's 3 things to do to test for nitrate. Sodium hydroxide, aluminium, and then warm gently. Now, the interesting thing is this. You realize in step 1, you added sodium hydroxide. If you're adding sodium hydroxide, you realize that at the same time, I'm doing also test for cation, right? Yes, you're right. So in real life, when you add sodium hydroxide, don't just add and then just leave it as it is. Don't just do step 1, 2, 3 brainlessly consecutively. Actually, for step 1, when you add it in, you are actually doing a test for cations at the same time. You can look out for precipitate to find out what's the cation present. After that, you can add aluminum foil and you warm gently, right, to find out whether nitrate is present. Now, how do you know if nitrate is present? By doing all this, and then you warm gently, you realize that, oh, sure, I start to see effervescence. When effervescence occurred, and then you see a colorless, pungent gas evolved, and that particular gas turns your moist red litmus paper to blue. Teacher, this one I know already. Colorless, pungent, moist red litmus paper blue. What gas is produced? Ammonia gas is produced. If ammonia gas is produced after I've done step 1, 2, 3, I can conclude that nitrate is present. So as mentioned here, sodium hydroxide, when it's added, it can also be a test for your cation. Okay? Take this time, let's pause. Okay, give ourselves a good 10 seconds or good 20 seconds to just review the anion test that we've gone through so far. Okay, there's total 5 anions, 4 different tests for them. Give me different results for each of them. Okay, let's pause here for the next 5 to 10 more seconds. Okay, just to have a sense of what the test for anions are. Okay, 5, 4, 3, 2, 1. Okay, can I have you all put a thumbs up just to check you are still with me, and then we can carry on to the next segment. Okay, good. Okay, last part ready, just to do, so I'll finish up with this worksheet. So once this worksheet is done, then we will end off here. The next lesson will carry on with the test for gas and etc. Okay, so this one here, let's get a bit more active in the chat again. Okay, first thing, question 2. I add dilute nitric acid. What is this testing for? Anyone can tell me? If I just add dilute nitric acid, what is the anion that I'm testing for? Carbonate. Good. Okay, so actually adding acid is a test for carbonate. But normally the question, if they never say just add nitric acid, they say add nitric acid followed by blah, 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 blah. This one here is actually the main thing. So nitric acid followed by aqueous silver nitrate. So if I'm adding silver nitrate, anyone can tell me what is the anion that I'm testing for? Type in the chat group. Type in the chat in call message. Anybody know? Silver nitrate, what am I testing for? Chloride is correct, but it's not only chloride. When you add silver nitrate, you can test for 2 of the anions. Alright? I saw chloride and iodine. Iodine is wrong. It's iodide. So silver nitrate actually stands for chloride or iodide, depending on what is the result. So this is the test. What I have here is the test. What is the result? White precipitate form. So this one is the results, white precipitate form. Now, white precipitate is formed. Can anyone tell me what's the name of the precipitate form? Okay, very good. I saw straight away, very fast. The precipitate form is actually your silver chloride. Okay, so let's write the formula, AgCl. So silver chloride is the precipitate form. You added silver nitrate. Where did the chloride come from? The chloride came from the salt. And hence the N ion present in the salt is actually chloride ion, Cl minus. Okay? So this is for question 2. Thumbs up if okay. Okay. Now question 3 gets a little bit interesting because if you read the question carefully, they tell you that actually there are 2 N ions present in the salt solution. 2 are 2. Okay, so let's look at the first one. On addition of excess dilute nitric acid, a gas is evolved which form white precipitate in lime water. So I got my first precipitate here. After that, when no more gas evolve, I add barium chloride and another white precipitate is formed. This white precipitate number 2. Okay, so let's start off again. Someone type in the chat group, help me. If I add dilute nitric acid, what am I testing for here? So I'm very clear cut. Didn't never add anything else. I just add acid. Come, type. Somebody type something, please. What is adding acid for? Yes, carbonate. So I add acid here to test for carbonate. How do I know if carbonate is present? Is when you see this gas evolved. This gas evolved here is your carbon dioxide. This white precipitate form here is, okay, we shall decipher later. Next one, no more gas evolved. I add barium chloride. This is test for what anion? Anyone can tell me. If I add barium chloride or barium nitrate, whichever one of them, what is the anion that I'm testing for? Somebody type, somebody say something. Anybody? Look at your previous page. If you add barium chloride, yes, you're testing for sulfate. Good. Right? I hope you're looking at your previous page to find out what is the exact anion that I'm testing for. So if I add barium chloride, actually I'm testing for the sulfate ion and a white precipitate form. Now, okay, who here can talk? Zachary Ho can talk. My Michael 31 Zach Ho. Can you talk? Maybe he's not there. You're in a club. Or what kind of club? Okay, never mind, let's not continue with that conversation. Okay. Anyone want to try? Edward, you help me. I know you can talk. Edward, come.
Well,
What's the first white precipitate?
I don't know.
Okay, if you do test for carbonate, a gas evolved.
Calcium carbonate.
Okay, so this is actually your first precipitate form is calcium carbonate. Okay, and if calcium carbonate is formed in the, which is the white precipitate form in lime water, right?
Yeah.
So this is the first precipitate. Can you tell me what's the anion present?
Barium sulfate.
No. That's the white. Okay, so the second precipitate is barium sulfate. But what is the anion present based on your 2 observations?
Damien, help me out. Damien, say something, please.
Stop depending on others. I can think of
Okay.
stuff.
Carbonate and sulfate.
So if you got the white precipitate, which is calcium carbonate forming, what is the anion you can conclude there? You see here. I got test A, which consists of this highlighted in blue here.
Okay.
I got test B, which is this whole thing highlighted in yellow here. Then this is the test A results, the white precipitate form. White precipitate form is calcium carbonate. So can you tell me what is the test A testing for?
Carbonate and
Carbonate. So if I'm testing for carbonate cation and it gives me a positive result, which
Mhm.
means carbon dioxide gets involved. So
Yeah.
what's the conclusion?
The carbonate ion is present, which is
Yeah.
CO3 minus.
Can? Okay, so this is actually how I need you all to be able to conclude and see the relationship. Okay, then I think the next one I shall not trouble you already. So next one I can, because barium sulfate is formed, I know that sulfate is present in the salt. Therefore, I know that SO4 2 minus is present. Okay, can? So this is for 3. Now, 4, 5, 6, I'll let you go and try as homework. I shall not bother you anymore already. Okay, because it's going to be 4 o'clock already. So do the question 4, 5, 6 as homework. We will carry on with the remaining with worksheet 3 and the subsequent questions. Okay, tomorrow onwards. Okay? Please go and revise back on these two important because tomorrow lesson onwards it's gonna be a lot of question doing, getting familiar with the tests and the results. Okay? Yep. So that's all from me. If you got no questions, you can leave already. Those who got questions, you can stay back. Okay, you can ask me. Okay, I'm gonna stop the recording now.